Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be doing some GCSE chemistry, specifically looking at the pH scale, neutralisation reactions and also strong and weak acids. So if you do enjoy the video, please let me know by liking the video, share it with someone else so they don't miss this key revision, and also feel free to subscribe so you don't miss any uploads from me, but also be part of a wonderful community here on YouTube of lots of students who are trying to get the best grade they can. So thank you so much if you've already subscribed, by the way. I really do appreciate all your support, and let me know in the comment section below. Please let me know what exam board you are currently studying for, whether you're in your year 11 final year of GCSEs, whether you're just starting, maybe you're in year 9, you're looking at the content that's coming up, whatever the case may be. Even if you're doing your A levels and you're looking back at GCSE revision, hello and welcome. I hope you find the video helpful. So what actually is the pH scale, and what do we mean by pH in general? Well, pH actually stands for power of hydrogen, and it's a way that scientists mathematically express how acidic or alkali a solution is in terms of a logarithmic scale or a mathematical scale. And you don't need to know much more than that at GCSE. As you go into A levels, you'll need to kind of calculate the pH of substances and use a bit of maths to do that. But at GCSE, you really just need to know that it's a way of looking at how acidic or basic or neutral a substance is based on how much hydrogen ions they have. And remember, hydrogen ions, they have a H plus symbol or a plus charge as well. So that's kind of what you would be looking for if you were looking for an acidic solution. Alkali substances or basic substances often have an OH minus ion associated with them, and neutral substances don't really have either of these, or they have them in equal contribution, so there's about the same of each, and they kind of cancel out in that sense. So we're going to look and explore this a bit further. So there's a few different ways we can actually test the pH of a substance and determine whether it is acid, basic, or even neutral. The first way is probably the most common way you're used to seeing, and that would be using universal indicator. This is like a dark brown, black substance where you add a couple of drops to your solution, your unknown solution, and it will turn a certain color. So if it's a red color that it changes to, that would tell you that it's an acid. If it's a purpley blue color, it would be an alkali. But also if it's green, it would be a neutral substance. The one thing to say about this is because it is a qualitative method, it's subjective. So you're looking for a color change. That means that it could be hard to identify if it really is purple or if it's really blue. It can be subjective depending on the person looking at it. But also if the substance itself has a natural colour to it, it can be even harder to identify that colour change. So a way to mitigate this could be to use a white spotting tile to actually see that colour change more vibrantly. Another method of testing for pH is the use of litmus paper. Now, you can use blue litmus paper in certain solutions, and if it turns red, it tells you that there is an acid present. If the red litmus paper turns blue, that will tell you that there is an alkali present, and if it turns purple, you will know that it is a neutral substance. Again, because it is a colour change, it is subjective, and therefore that is one of the negatives or downsides to this, the fact that you're looking at a colour change, it can be hard to interpret. Another way that's a lot more effective in the sense that it gives you a definite figure. It can tell you exactly what you're looking for without subjective interpretations, is using a pH probe. Now, pH probe is a device where you place it into your solution or your substance and it will give you a number. This is a quantitative method. So without trying to determine, is it an acid, is it an alkali, is it on the borderline, it will give you a number from 1 to 14 and it will tell you exactly if it's an acid or an alkali, but also if it was a strong acid or a weak acid because of the number. The lower the number is, the more acidic the solution is, essentially. So when we talk about acids, bases, alkalis, there's a lot of terminology here, but there's two words that really get mixed up, and I want you to know the difference. So the word base and alkali are when people use them, they are talking about the same thing, but they are slightly different. So a base is something that can react with an acid to form a salt, which is neutral. Water is also formed, which is also neutral. However, an alkali is a base that is soluble in water. It can essentially dissolve. Now, you can use these words interchangeably, but I have seen in the exam before, they ask you what is the difference. This is a rare question that could come up, but it's worth just being aware of the differences between the two. So when we look at the pH scale, you've probably seen this beautiful rainbow diagram before. This is of course, the scale using universal indicator, which we've just talked about. But the reaction that you need to know about is the neutralisation reaction. So when an acid reacts with a base or an alkali, it forms a salt and water. Now, we have talked about these reactions in a previous video, which I'll link for you at the end. But just be aware that this is a reaction that you do need to know. There are 3 different examples here, so let's go through them. We have nitric acid and iron oxide. Nitric acid, of course, being the acid, iron oxide being the base. Oxide or hydroxide, if you see those prefixes, those endings of the words, you need to know that those are bases or alkalis. These react together to form iron nitrate. Notice that the salt name has changed from nitric to nitrate. You're using the acid to determine this. Like I say, the video I'll link at the end goes through all of this in a lot more detail. And in each case of these, water forms. So another example could be sulfuric acid, another type of acid you need to know about, reacts with sodium hydroxide, example being another base. This forms sodium sulfate and water. Sodium sulfate is the salt. So you get the idea that these reactions will always form the same sorts of products. They'll always form a salt, they'll always form water, and they are neutralization reactions for a reason. They are neutral in their products. So sodium sulfate, iron nitrate, lithium chloride are all salts. They have a pH of 7, and water in its natural form will also have a neutral pH, and therefore if we tested it using universal indicator, it should go kind of a green color. So lastly, we're going to talk about strong and weak acids. Now, strong acids will completely ionize or dissociate in water. A couple of examples could be hydrochloric acid, sulfuric acid, and nitric acid. These are the 3 types of acids we have actually discussed a lot at length about, specifically when naming salts, if you've watched that video. So you'll know some of these acids already. You need to be able to quote a strong acid as being able to completely dissociate in water. A strong acid, by the way, is not a concentrated acid. Remember that concentration is just the number of particles in a given volume. So you can have a strong acid in a dilute solution where there's not much of the acid, but it's still a strong acid. So concentration is not the same as strong, and weak is not the same as dilute. Those things are completely separate from one another. If you want to have a look at what I mean by strong acids, you can see HA stands for the strong acid. It fully dissociates into the 2 ions that make it up. So you've got the H plus ions, which tells you that there's an acid there, and also the anion, the negatively charged ion that's also in that solution as well. So let's go, for example, hydrochloric acid, HCl is the symbol. Hydrogen is obviously in there because it's an acid, but also the Cl, the chloride ions, are forming as well, completely dissociate from the original structure. A weak acid, however, only partially ionizes or dissociates in the water. So good examples would be ethanoic acid, acetic acid, citric acid. There are loads and loads and loads of different versions of these different types of strong and weak acids, but these are some key examples. And as you can see, instead of having a straightforward arrow, you actually have an equilibrial arrow because there is a back and forth reaction going on here. It only partially ionizes, as I said. So something to be aware of. These sorts of things can come up in the exam, and it's worth just being aware. And that's it from me today. I've been the GCSE science teacher, and you have been curious. If you did enjoy the video, please give it a thumbs up, share it with someone else so they don't miss out. And also please do subscribe if you haven't already. Thank you so much for your support on this channel. I really do appreciate it. If you want more help with biology, chemistry, or physics GCSE, please do check out my Instagram and TikTok. All of it is at the GCSE science teacher. And also do have a look at the playlists and the videos linked at the end of this video if you want to revise some more. In the meantime, have a great day, and I will catch you in the next one. Take care.